Professor, welcome. Thank you so much for joining me.
Well,
it's mind-blowing, but what does it mean for somebody as ordinary as me?
Well, first of all, Jane, thank you for the opportunity. This is a red-letter day for physicists. What does it mean? Well, let me give you an analogy. Suppose you imagine sitting in front of your TV watching a show, but with the sound turned down. You might enjoy the motions, but you wouldn't know the full story. Now turn the sound on, and you get the full story. We can now hear the universe for the first time with this new technology. So not only will we watch it with light, we will hear it with sound. And one of the wonderful things about that is it's a more complete story, just like watching TV.
So what exactly are we now listening for?
So what we are listening for are the minute undulations of space and time, which is a very strange concept because normally we don't think of space as a thing, we move through it. But Einstein's equations tell us that space and time are actual things that you can rip and pull and rend, and this technology allows us to hear this for the first time.
But what are we likely to find? I mean, we heard something there about the beginning of space. Will we actually see how our universe started?
Well, as of right now, we look with telescopes and we use light. And the only thing that we can see is there's a curtain out there. It's called the cosmic microwave background. It's a form of light the kind that you find in a microwave. That's why we give it that name. But you can't see anything before that. You see, the cosmic microwave background was a picture of our universe that was taken when the universe was 380,000 years old. We live in a universe so clever, it took its own baby picture. But you can't see before that. Now, with this new technology, we can hear what happened before that 380,000 years and use that to explore what was the universe like all the way back to the Big Bang. It's just, for a physicist, it's an amazing thing. It's like opening the door to a dark room and suddenly turning on the lights. That's where we are, and that's why it's like Galileo looking with the telescope.
It's incredible. When will scientists actually start doing this?
So it's going to take a few more years because what happens with this technology is it doesn't quite work like a telescope. We have two such detectors currently, both here in the United States, and they constitute the LIGO project. There's another telescope in Italy and a telescope in development in Japan. When all four of these pieces of technology are working, then we will be able to pinpoint where the sound is coming from. We will be able to map out how the universe is being restructured and by space and time bending, and it's just going to be that turning on the lights in a dark room.
Well, you've certainly turned on the lights for me. Thank you so much for putting all that into plain English. Dr. James Gates, thank you.
You're quite welcome, Jane.